So I want to share with you guys my desktop. And so look at this, please. So this is probably was one of your question, and so I guess most of you have done it right. You're able to find the reaction and do the bending moment. So I have a comment for you. I comment. Okay. So this comment is simply the shape of the bending diagram. I had so many of you talking to me and say, okay, Tahir, we've done the diagram. It looks like yours, but it's mirrored. It is mirrored. Okay. So, for example, when you look at this cantilever beam at the very bottom here, okay, so you can see here is my beam, which is a simple beam with overhang to the right side. And when you guys have done this one, guess what happens? I'll show you what you guys have done. So I guess you went this way, so completely mirror. So you're, for example, your bending moment, the 18, you have done it below the beam, and your 36.5 is simply above the beam. Okay, why is that? Why this is happening? Here is the secret. Guys, you will see both what you've done is correct and what are in this document, both of them are correct. In different countries of the world, they draw the bending moment on different sides. Okay, so some of them they draw on the tension side, and some of them they draw the bending moment on the compression side. However, let me explain for you that what you see, I know last year, really what you learn is this. So last year, what you learn is you simply, for a simple beam, your bending moment diagram will be on the top. So on the top, it means it's the compression side. Same as this diagram here. I'm going to point out to this diagram. We can do it on the opposite side, and as I said, both are correct. It depends on where you learn. Typically in the states, they use this kind of convention. They draw the bending moment diagram on the compression side of your beam. Where I learn, and maybe somewhere else on the earth, they draw the bending moment on the tension side. Now, as I said, both are correct, but I will convince you in the next minutes or so that this way is not really the best for our concrete classes. Okay? So really in our concrete class, if you wish, and again, that's an option for you, is not a must. I want everyone to draw the bending moment this way. And I will tell you why. It's not secret. You will know why this is a very handy for concrete design. Maybe in steel, yes, it has some sense, but in concrete, it's very important to do it this way. Okay, now let's run let's run this question. Okay, so I'm gonna go here. I'm gonna say, you know what? Give me a new, add here document. Let's say if we can add edit. I don't know. I want to add here another page. Insert and insert a blank page. Here we go. We have an empty page. Okay, let me ask you guys. I'm going to show you here a beam, and this beam, I'm going to draw the beam itself, not really a center line. So I'm going to do this. I'm going to do here a column, and then your beam, another column. Okay, guys, what you see on my screen is simply it's a simple beam with overhang. From this column to this column is your simple beam, and from this column to the end, this is your cantilever. Now, if I apply loads, okay, so let's say this is a gravity load, okay, I apply this load on your beam. Anybody to tell me under this load how this beam will deflect? Okay, so I'm gonna show it for you because I don't have really the best tool, but really, this is what happens. Your beam will bend this way, and then probably is gonna bend Okay, probably I need to change color. I'm sorry, I'm going to waste a little bit of time here, a minute or so, to use a different color, because simply maybe you guys don't see it best right now. So let's change the color and let's make it blue. And I'm sorry, oh my God, I'm going to have to bring this one back to red, and I'm going to say line, and then I'm going to use this one as blue. So here's blue. And what you see me drawing right now is simply, as much as I can, the deflected shape of your beam. So the beam, oh my God, why it does keeps doing this? So blue again. Oh my God.
That's okay, sir. Just do the red one. We can.
I want you to see better. So I'm, you know what, like I'm going to maybe, it's very important for you guys. This is important, it's not waste of time. I'm trying to show you why doing the bending moment diagram on the tension side is good for this class. It's going to take us like, maybe a few seconds, but we should have a better results. If this is in class, it will be done in a matter of a second. But nevertheless, we can still do it. I'm done, guys. I'm done here. So in red, this is the shape of the beam before you apply the load. And when you apply the load on the beam and the cantilever, I guess, I know it's going to be a curved shape, but the cantilever will bend down and the simple beam will bend down as well. Now, let me ask you, when under the loading, where do you think the tension side of your beam? Okay. So for example, above the column, the tension, I'm going to show you a couple of locations and you tell me where is the tension. So you think the tension will be on the upper fibers of your beam or will be on the bottom fibers of your beam? That's on the support.
Bottom.
The bottom.
So you think when the cantilever bends down, the bottom fibers will be in tension?
Yes.
Can you feel it? Like, can you have your hand and bend your hand down and see where is the tension side?
And the cantilever would be on the top, and the other part would be in the bottom.
Exactly. So look at this, guys. So conclusion is the arrow here, it shows you those fibers here in this area is in tension. However, in the middle of the beam, I guess this side here will be in tension. Guys, I guess by now, like last year you learned that concrete is really good in compression and not really great in tension. Are we in agreement on this statement? Concrete is fantastic in compression, bad in tension. Do we agree?
Yes.
Okay, thank you. So what happens in tension? What do we do in tension if concrete is bad in tension? The answer is in this course, we will place rebar in tension. We will place rebar in tension where concrete is not the best. So guys, if I ask you, if I were to delete, if I go back and simply delete all those blue lines, because now you understand where is the tension. Where is the tension? Now, if we were to reinforce this beam, and I'm gonna, place some, make some rebar. So, okay, so I'm gonna put some rebar, and I will use, let's say, green. If I reinforce the beam itself, should I place my rebar at the bottom, or should I place my rebar on the top, between the columns?
Top. Bottom between the columns.
Between the columns. Remember, I'm gonna say it one more time.
Oh.
Concrete is bad in tension, good in compression. So in compression is good on its own. In tension, we have to add rebar. So I'm asking you, between the columns, my rebar should go on the top or on the bottom? Between the columns.
At the bottom.
Thank you so much. Here we go. So this should be the rebar between the columns. Let me ask you one more time. How about if we do the rebar, reinforce the cantilever? When I reinforce my cantilever, should I place my rebar on the top or on the bottom?
On the top.
On the top. So thank you so much. So here we go. This is really the main reinforcement of your beam. Now let me ask you, if we compare this to our the other, okay, so I'm gonna switch back. So again, this is the same problem here. I'm gonna minimize it and put them side by side, okay? I want you guys right now to look at the bending moment. And I'm sorry, oh my God, that's not really good. So let's focus here. Let's get this. Guys, please watch this. Which one you think the bending moment is best in our class? When you look at the bending moment on the left and you look at the beam reinforcement on the right, you can see if you draw the bending moment the way I like on the left side, you will see it also tells you where to place the reinforcement. You can see the bending moment between the columns. Here is the bending moment and same place where you place the rebar at the bottom of your beam. On the cantilever side, you can see the bending moment is on the top, and also we place the rebar on the top. Okay. So anyway, so hopefully from this discussion you understand that drawing the bending moment this way, I'm gonna maybe expand. So drawing the bending moment this way, it works best in our class because simply it tells you where to place the rebar. Is anybody, everyone is following, guys? Are you following? I have a question here, I guess. Jelly, go ahead.
No, I don't have question. Sorry.
Okay, thank you. So guys, with this, I have a couple of minutes for questions. So if you have any question, let me know now. Diego.
So you said that you don't mind if we put the tensioner on top, on the bottom. Do you want us to clarify somehow where we are putting it?
Again, drawing the bending moment is completely up to you. Whether you want to follow this convention here, it's fine. And if you draw this one in a mirror, so it's exactly the same, but it's mirror, which means it's going to look like this. Okay. For me, it doesn't matter as long as you know where to put the reinforcement. Remember, you cannot switch the reinforcement. So if we go back to this picture here, you cannot. That's a mistake. If you draw for me, place the rebar of this green here on the top, and you place this one here at the bottom, this is a fatal mistake because simply go to the jail. Because simply when the cantilever wants to bend it down, the tension will be here. There's no rebar, so your cantilever will fall to the ground. So your question is, do the bending moment the way you like, but please place the reinforcement in the right way. I recommend that you follow this convention here, which is mirror from what you've done last year, so it tells you where to place the reinforcement. Did I answer your question?
Yeah, sure.
Okay, thank you. Next, any other question, guys? Any other question? If not, then it's 9:50. I will see you guys in 10 minutes in surveying class. Thank you and have a good surveying class.